All right, good afternoon. Almost good evening. Is there anybody out there? Hey. So I was just told that I'm not only competing with Jeff Woolsey, but also Mark Krasinovich. So that might explain the large room with lots of empty seats, and everybody over on this side. Not sure why that is. I'm Rob Willis. I am a principal program manager in the Windows Server and System Center engineering organization. And we're going to talk about automating System Center deployment with the PowerShell Deployment Toolkit, or PDT. PDT is a freely available set of scripts and knowledge, community supported, available on the TechEd gallery, documented through the Building Clouds blog. How many, just kind of show of hands, how many people here used or tried the unified installer from System Center 2012? Wow. Okay, that's 4 more hands than I usually get. I was the program manager for that. A lot of what we learned through that exercise of creating a unified installer for System Center went into the creation of the PowerShell Deployment Toolkit. But this is not a product feature. This is a toolkit available on the gallery, as I said, community supported. So I'm going to start with some questions. And those of you that may have watched the MMS version of this session, the answers to some of the questions are different, so no cheating. How many products make up System Center 2012 SP1? Just shout it out. 7? 9? 1? The answer is 1. The correct answer is 1. System Center is the product. There are multiple components, but the only thing you can actually buy licensed from Microsoft is System Center itself. How long does it take to deploy System Center 2012? Yes, all of System Center 2012. How long? 2 hours. You read the brief for this session, didn't you? Too long? 2 years? We get it's a management problem. And actually, that's a really good answer. So we got lots of management software that deploys software, but how do you get the management stack in place in the first place? We typically see anything from a couple of days, a week, a couple of weeks, or even longer for real deployments at System Center. So the answer really is it just takes too long. How many screens does an installation take? So as you're clicking through all those setups, including all the prerequisites, including SQL Server, how many screens of information do you click through and answer something on to do that full deployment of everything in System Center? Too many. Actually, so for Unified Installer, I counted them. It was 422. We do a very different, we have very different capabilities in PDT for much more complex installations, and I lost count somewhere around 500. Again, it's just too much stuff to go through. How many post-setup integration tasks are there? By that, I mean after you've installed multiple components and you need to make them talk to each other, how many of those post-setup integration tasks are there? Too many. The answer usually is, what on earth is a post-setup integration task? We have lots of customers that use 1, 2 of the components of System Center, but not many that use all of them. And really, to get the full capability, the full power of System Center, you need to understand how all these things work together. Who's afraid of XML? Come on, admit it. Okay. This session does involve manually editing XML. Don't be scared. I've got somebody guarding the doors. Nobody run away. It's actually not that bad. But I just want to let you know this is a toolkit that currently has no UI other than an XML editor. But it's actually pretty easy to use. So I'm actually going to start with a demo. Actually, 2 demos. The reason I'm going to do this is it takes a little while for these things to complete. And I want to make sure that we get to see all the goodness at the end of this. So I'm actually running from 5 different demo environments, and I'll explain what these are as we go through them. But I'm just going to kick off a couple of installations. I'm going to do a full deployment of System Center, so all components, all roles of all components. That's on this first server here. So I'm not going to really explain a whole lot of what's going on right now, apart from those are all the components that are being installed on about 14 or so individual servers. That's a full deployment of everything. The second one, on this second demo environment here, is actually going to be a high availability deployment. So this one has SQL clusters, has VMM clusters, has multiple of individual roles for a couple of components. This might be a typical service provider deployment. And something I will point out here, Windows Azure Services is also part of this. This is the current version, not the Windows Azure Pack that was announced on Monday, the current version for 2012 that's really targeted at service providers. So I just want to start those off 5 minutes into the presentation here, and we're going to come back through this and look at exactly how those are doing and explain what they're doing. So that was a full deployment and a highly available scale-out deployment. So let's frame the problem a little bit. System Center 2012 is a product, but it does consist of 7 components. Some would say it's actually 8 because Orchestrator now includes something called Service Provider Foundation, which might be considered another component. But officially, System Center consists of 7 different components. But if you go a level deeper, each one of those components consists of a number of roles. And this, by no means, is an exhaustive list of all of the roles. Configuration Manager, for example, has a lot more roles. Management points, distribution points, reporting, etc., and that may not be on this list. But this is a fairly typical list of the roles that people would install if they're installing all of System Center. If you take this a level deeper, all of those roles have prerequisites, of which there are quite a lot. Some combination of this set of things has to be installed before you can install the role. The message here really is it's a complex undertaking. What we want to do is simplify this and make it a single installation experience, relatively straightforward to deploy all of that stuff and not have to understand too much of the complexity that exists underneath it. So the experience of installing System Center today goes something like this. First, you define your deployment. And I don't care how much automation you use, you always have to do your planning, right? So I'm not going to tell you how your System Center deployment should look. You need to do the appropriate planning and define what your deployment is going to look like. Then you're going to go and download all the bits, right? Well, typically you're going to download a component, and then you're going to try and install it, and it's going to tell you, well, you're missing the SQL command line utilities. So you go and download SQL command line utilities if you can find them, and you try and install that. And it says, well, you need SQL native client before you can install command line utilities. So then you go and download that. At some point, you've downloaded all of the bits. Anyone want to take a guess how many individual downloads you have to do for everything you need to deploy all of System Center? 100? It's not quite 100. I'm not going to tell you the answer yet. It's coming up in a little bit, but it's a lot. Then I install a bunch of servers, whether that be a physical server or virtual servers on any virtualization platform. I have to have a bunch of server OSs installed for me to go and install System Center against. Then I create some service accounts, if I can figure out what the right set of service accounts need to be. Then I log on to each one of those servers that I've got installed. I install some prerequisites, and then I find out what prerequisites are missing. I go and install some more prerequisites. Then I wait for my clicker to catch up. Then I install SQL, and then I probably go and install SQL again because there was a feature of SQL that I needed that I wasn't aware I needed that I was missing, or I installed it with the wrong collation, or I did something about SQL that wasn't right. But somehow I get SQL installed the way it needs to be. Then I grant permissions to those service accounts, so some of them have to be administrators on the server that their component is running on. So I figured that out, and I grant those service accounts permissions. Then I install my first server role. Then I may, if I'm doing a distributed deployment, install further server roles. And then I need to grant admin permissions to the component I just installed so that whoever needs to access that is in the right group, whether that be a Windows group or a component group, to be able to get to administration functions for that component. And then I may do this strange post-setup integration thing. And then I go to my workstation where I'm going to be running my admin from, and I install a console, and I run that console, and then it says, well, which server do you want to connect to? Because it doesn't know, unless it's Configuration Manager, which does. So I connect the console to the server. Then I install some agents. And finally, I get to manage something. Okay? That's really the experience of installing System Center today. With PDT, we want to dramatically simplify that and automate the vast majority of those steps. We don't do everything. There are still some things we expect you to have done beforehand or you're going to do after the fact, but the list of things you actually have to go through is significantly reduced. What we're going to do is step through each one of these stages of deployment and explain how PDT automates or simplifies that particular step. So start with define your deployment. This is where our first scary XML files comes in. Right? We have PDT actually consists of 5 files. The download off the TechEd gallery itself is around 50K. It's very, very small. One of them is this thing called the variable XML file. That's the only one that you need to edit. Right? Everything else is you just run or it's there for information purposes for PDT. But variable.xml is where you define what you're actually going to go and deploy. The sample that comes with PDT has all the roles in it. It does a single server per role, and that's so that you can install on the least number of servers, but it's actually not a very good example deployment. What you put in variable XML, global settings. So what's the username and company name you want to register the software to? What is the service account and password of the account that's going to do the installation, so the installer service account? What is the source path to all the media, and we'll get to how you get that in a moment, all the media for what you're going to install from. Then optionally, you can also put in product keys. So if you enter product keys in variable XML, you'll get a fully licensed deployment of System Center. If you omit product keys, you'll get an eval installation, 180-day eval installation of everything, including SQL and System Center. You can switch it from eval to license, and I've got a reference for that at the end of the deck here. Then you specify settings for each component that you're installing. You don't have to install everything. You can pick and choose what you want to install. But any of the components you're installing, typically all you need to supply is the service account and password for that service account that's going to be used by that component. Then you specify which servers you want to place each role in your deployment on. If it's a database role, you also need to specify the SQL instance. Most people are just going to use the default MS SQL server, but you specify which servers each one of your roles is going to be deployed to. And then for those SQL roles, for each SQL instance that's going to get installed, you have to say which version of SQL. We support both 2008 R2 as well as 2012, and what admin group you want to have access to that SQL instance once it's installed. The good news is the installer script itself validates all of these settings before it actually begins the deployment. So if you put anything in there wrong, it's going to block and stop you from doing that. If you get a service account wrong, it's going to block you. If you try and combine roles onto the same server that aren't likely to work very well, it's going to block you. So we validate everything before we actually start the deployment. So here is a simple sample XML file. This is a simple example that just deploys Orchestrator. We'll just use it to illustrate what you need to put in here. And all of this is in the sample. All you need to do is edit what's there. So I'm specifying the installer account and password that's going to be used to actually do the installation. This isn't used as a service account for any component. It's just used to actually do the installation. I'm saying what my service account or what variables I need to specify for, in this case, the Orchestrator component. And again, this is just a service account or password. If there's anything else needed, the variable is also included in the sample as part of the download. Then I say which servers I'm going to install to. In this example, I'm doing a 3-server deployment. I have a separate database, and then an Orchestrator server, and then I have a remote desktop server I'm actually running my consoles from. I say that I want the version of SQL to be 2012, and my admins group is just called SQL admins. And in this case, I haven't specified a product key, so this would do an evaluation installation of Orchestrator. Okay, so that's define your deployment. That was one component. Doing 7 isn't really a lot more complex. It just has 7 component sections and more role sections. Pretty simple. Then you go and download all the bits. For that, we have our first script. This is the PDT downloader. What the PDT downloader does for you is download everything you need. So the System Center components themselves, and it actually downloads the evaluation versions of all of the System Center components, Any prerequisites that are needed by them, such as ADK, the SQL native client, report viewer, WSUS, there's a big list of prereqs that I showed earlier. Any of those that are downloads, the downloader will go and get them. It will get the eval versions of SQL, both 2012 and 2008 R2, as well as the latest service packs for those. It'll download SharePoint 2010 Foundation, that's used by Service Manager Portal. It will download management packs and integration packs. Right now, it actually doesn't download Windows Server 2012. Right? The link to the public download for that changed, and now you actually have to register to download that. So that is one that you do have to manually download right now. I'm trying to find a solution to that. But it downloads all of those things for you. Then any of them that require extracting, it goes and extracts them. So anything that's in an ISO, it goes and mounts the ISO and pulls all the files out there. The System Center 2012 components actually come as WinRAR files. It uses WinRAR to extract the contents of those. The SharePoint module that's used to deploy SharePoint is a zip file. It unzips that. Then anything that needs to be run to go and get other things, it also runs for you. So ADK is a weird one. It's about a 1 meg download. When you run it, it downloads about 1.5 to 2 gig of more stuff. Right? So the downloader automatically runs that for you to make sure you've got a full download. It also runs the Configuration Manager downloader. So if you're familiar with the Configuration Manager installation, when you run setup, it says, I need to download some other stuff. What path do I want to put it to? Or I've already got them downloaded. Here's the path. This actually just runs that downloader and it gets all that stuff for you before you start. The goal is you'll have everything you need so that you can actually do a complete offline deployment with no internet connection if you want to. And any of those downloads that are then self-extracting executables, it also runs those. So once it's done, everything is completely extracted and ready to deploy. It will also slipstream SQL 2008 R2 Service Pack 2 into the media for you, so you don't have to do a separate Service Pack installation. It does require that you run this on Windows Server 2012 or Windows 8. The reason for that is we use the capability in that version of Windows to mount ISOs to be able to extract that. So we require you run on Windows 8 or above. And it does require that you have WinRAR installed to do that extraction. There is one option on this script. It's a dash deployment only. If you use that, it will read your variable file and calculate just the things that you need for your deployment, not automatically do everything. So if you haven't got everything pre-downloaded and you don't have as much time or you don't have a great internet connection, you can run deployment only. The whole thing is restartable. So if something breaks halfway through, if your internet connection goes down, you just restart it. It won't re-download anything you've already got. It'll pick up where it left off. So let's show you what that looks like. So this is my third demo system here. And you can see in my installer folder, all I have is Windows Server 2012. Again, the download for that isn't working right now, so I've left that downloaded. The downloader script is real simple. All you do is run downloader. It has one option. I'll show you that option in a moment. And it will go and determine what you need. And so here's the answer to how many downloads are there. 71. It was 56 at MMS, but when I added Windows Azure Services, it added another 15. So 71 downloads. This will go through and get everything you need for you. It's about 13 gig of download. On disk, once it's done, it's around 30 gig. On this particular system, it takes it about 45 to 50 minutes to download it, but this is in one of our data centers with a really fast internet connection, and I think the servers it's downloading from may be in the next rack over. So it's pretty quick. On my own personal home connection, it takes about 2.5, 3 hours. The second thing I want to show you is the deployment only option. Right? So on this system, I have that variable file that we looked at a moment ago that's just going to deploy Orchestrator. And in this case, again, I just have Windows Server here in my installer folder. When I run downloader, I'm going to say deployment only. This one's going to take a little while longer to start because it's calculating from that variable file what it needs, and it only needs to download 7 things. So it's not going to download everything that you don't need. It's going to download just what you need for this one deployment. The whole thing is restartable. So if I were to go to a system that had everything already downloaded, and let's say I was missing something, so if I were to delete Silverlight, for example, when I run the downloader on this one, it's still going to go through and calculate based on all 71, but it knows that I'm only missing one, so it only downloads that one thing. So if it needs to be restarted, or if we release a new version that has additional prereqs or additional components it needs to download, you can just rerun downloader and it'll top up your existing download with everything you need. So now I've got all the bits I need to do my installation. Next thing is I need to install a bunch of server OSs. And PDT doesn't care what you install to. The only thing it requires is that you have servers that you're installing against. If they're existing servers, if they're physical servers, if they're virtual servers on Hyper-V or any other platform, as long as they're the right Windows Server version, we don't care. So this is an optional component that if you want to use it to create VMs for you to deploy against, it will do that as long as you're using Hyper-V. Again, we don't care if you're using a virtualization platform. We will run on that. Well, we do care, but you know what I'm saying. But if we're going to create them, we're going to create VMs on Hyper-V. The only requirements, if you're creating your own VMs or using your own servers, is their Windows Server in the right version. 2012 works for everything except for the SharePoint portal for Service Manager, which needs to be 2008 R2. They're domain joined, they have WinRM enabled, and you have administrative permissions to those. Everything else we take care of. But if you are going to use the VM creator, you specify how many servers you want. There's some defaults for the host you're going to create it against, what you want the VM names to be, and it'll use a sequential count to name VMs if you want to do that automatically. How many processors, how much memory, all the settings for that VM, what domain to join. There is an example of all of this in the download, the sample download in PDT. Optionally, you can override any of those settings per VM. So if you want to have specific names for your VMs, you can do that. If you want to have database servers that have more memory than all your other servers, you can do that. You can specify that override per VM. And then the VM creator actually validates that all the resources it needs to do that creation based on what you specified exist before it goes ahead and creates them. This is a sample, again, from the variable file of what that looks like. And in this case, I'm just installing 3 servers. They would be called server 11, 12, 13, except I've got an override in here that says the first one I actually want to call SQL 01, and I want to give it more memory than the default. Pretty simple set of parameters you pass in there to go and create that. I'm not going to do this one live. I've got some screenshots just because I don't have enough Hyper-V host to do all of this on in one demo. So this is the VM creator that actually created all the VMs that I'm using to do this deployment right now. It's just 24 servers. You see the count right at the top there shows 24 servers, and they all get specific names. So you run VM creator. What it actually does is it uses the Hyper-V PowerShell. You need to have the PowerShell module for Hyper-V installed. It uses Hyper-V PowerShell to create the VM, create differencing disks or copy parent disks if that's what you want to do, create any kind of data disks. It then mounts that VHD and dynamically inserts an unattend.xml file with all the domain join information. So when that VHD starts, the sysprep will automatically join it to your domain. Then it starts it, goes through, creates all those VMs for you. After about 20, 30 minutes, in this case, I've got all my VMs created. There is a slight revision to this that I'm working on that will actually do a full lab deployment. So the current version assumes you already have AD. It's going to join them to an existing domain. The version that I'm working on that will be available in a month or so here will actually also create AD for you. So in this case, you see on this particular machine, I have no VMs at all. I run the VM creator. The first one actually becomes a domain controller. And as well as adding an unattend file to it, it also has an auto logon, and that auto logon will automatically promote that machine to a domain controller. So it promotes the first machine to a domain controller. You can see here it also copies all of the source for the deployment you're doing into that machine before it starts it. Starts the machine, AD installs itself, it reboots, comes back up, and you see while this is happening, those other VMs have been created, but they're now waiting, or they wait for Active Directory to be complete before they start, so that when they start, they can join that domain, because AD now exists, and then the domain controller waits for all of the VMs to start and be joined to the domain before it then actually starts its own deployment. So it's a one pass: create the VMs, create AD, join all those VMs to that domain, and then actually start the deployment all in one go. This is the next version that we're going to release in a month or so here. We'll include this capability for full lab deployments. So now I've got my VMs. I still have to create my service accounts. We don't automatically do that for you. I'm not assuming we have any permissions to AD other than regular user permissions. In the VM creator with Active Directory, obviously we have full permissions to AD, so it actually creates the service accounts for you. But in the regular deployment, you have to have the service accounts first. Then what you would normally do next is log on to each server. We're not going to do that. What we actually do is a remote install of everything that we need to do. These are really interesting challenges in doing remote installs. We really have two requirements. We need to be able to remotely execute a command line on a bunch of different systems, and the way we execute that has to have credentials delegation. What I mean by that is it needs to have permissions to go and do something against some other server, such as when I install my Operations Manager management server, for example, the first one, it needs to be able to create a database typically against some other database server. So that's double hop authentication. That's the credentials delegation. There's a number of different ways to do this that we considered. The oldest one in the book is WMI start process. That doesn't give you the credentials delegation capability, so that's out. WinRM is really the way we want to do it. WinRM by default is now turned on by default in Windows Server 2012, but the credentials delegation CredSSP is not turned on by default. Even if you turned on CredSSP, there's still an issue. One of the things you can't do with most remoting technologies is install a Windows update. Right? The Windows Update agent actually specifically blocks you from being able to do that for a number of different reasons. So it would seem like that might not be a big issue, apart from it doesn't just stop you from installing a Windows Update, it stops you from checking to see if a Windows Update is required. So any component that needs a hotfix, needs an update in place, that checks to see whether it's there as part of its prereq checker, where if you're running it remotely with something like WinRM with CredSSP, it gets blocked because Windows Update says, no, not going to allow you to do that. SQL Server 2012 does that. .NET Framework 4.0 does that. DPM does that. There's lots of things that get blocked in this way, which means we can't use the recommended Windows remoting technology, which is WinRM. So that one was out. PSExec is another interesting one. PSExec actually has a way around that Windows Update problem, and that is PSExec/S, which says run as a system account. When it's run as a system account, it doesn't count as remote. But when it's running as a system account, it doesn't have credentials delegation, so that's still out. Plus, a lot of anti-malware software still picks up PSExec as suspect, so we really didn't want to look at that. Orchestrator has this remoting run program activity. It's actually just a modified version of PSExec, so that doesn't work. Orchestrator Runbook Server, this is actually what we used in Unified Installer to do it. The Orchestrator Runbook Server can do this. It's a service that logs on locally with a service account, and so I can tell it to do something, and it's actually a local logon. But it means that we've got to have Orchestrator installed first, and we get a whole chicken and egg problem there, which we handled in Unified Installer, but it was a difficult problem, and we really didn't want to go through that again. What we actually did was we used the task scheduler, and this is really the simplest thing you can possibly imagine. Right? What we do is we remotely register a task with the task scheduler without a trigger, which means it's actually not scheduled, it's just a task. And then we remotely start that task, wait for it to finish, and once we finish, we check to see that it's done what it was we told it to do in the first place. So this gives us remoting, but with a local logon, so we get the ability to do credentials delegation. If anybody is, actually Mark's session's going on right now as well, the the automation for MVMC toolkit for automated VMware migrations that my coworker Mark Gosson wrote uses the exact same thing to do multiple deployments. It's a kind of interesting way to work around some issues. So we don't have to log on to each server. So what do you think we do next? Everything else. This would be a really long presentation if I went through each one of those individually. The next thing is the installer. This is the core engine, the heart of PDT, the one that does all of the work. This is essentially a distributed deployment controller. So it knows how to install something remotely, how to validate whether what it needs to install is actually already installed, or if it's just installed it, whether it installs successfully, how to sequence things, how to manage dependencies between multiple different servers, how to manage reboots if a reboot is required, and then how to gracefully handle cascading failures. One of the really interesting things of automating this is that dependencies between servers. I've got a whole set of servers that are doing things concurrently, but up to a certain point, they can just go through their sequence and do everything they need. But at a certain point, one of them is going to need something from another server to be complete before it can start. That's the dependency part. The cascading failure part is if I get to a point where now I'm waiting on someone else, but that someone else has failed to install something, that failure can cascade across multiple different servers across the entire deployment. What the installer does is understand what that means and will automatically and very gracefully handle that scenario so that if any prerequisite or a dependency has failed, it will automatically fail itself. So you get this situation, if one thing fails, you may get half of your deployment complete and half of your deployment failed, but just something that depends on the failure is actually what fails. The whole thing's restartable, so it's actually pretty easy. There are several phases to what this does. Administrators, so any service accounts that need to be a local admin, it will check to see whether they are, and if it's not, it will make it a local admin. It will install any Windows roles and features that are needed. What it actually does is it goes through all of the roles that you've defined for a specific server and calculates the sum of the roles and features that are needed and installs them in one pass. So if I'm installing multiple components or multiple roles on the same server, I'm still efficient in terms of how I go about installing all those components. If there are SQL clusters, it will install the SQL cluster, and it understands the dependencies between nodes in a cluster and when to wait for other nodes. Then it'll install any standalone SQL. Then it installs any prereqs, and at that point, it waits. Right? Everything up to here, it can do on a single server in a single sequence with a slight dependency check on the SQL clusters. Anytime it needs to reboot, it will just reboot. There's one exception to reboots, and that's if the system that needs to be rebooted is the system you're actually running on. Running the installer on, it won't reboot that. It counts that as a failure. If it rebooted that, obviously everything else would stop working. But if anything needs to be rebooted based on pending file renames, on Windows updates, or any roles and features reporting a reboot required, it'll automatically reboot that. At this point, though, it waits for dependencies, and then it starts installing all the roles. It also does all of the integration and some small configuration just as though it were another role, and I'll show you exactly how that works in a moment. All of the knowledge of how this works is in a different file. The installer itself knows nothing about System Center whatsoever. All it knows is how to do all those things you just described. It doesn't know anything about System Center. That's why the original post where we released this says this is a toolkit that can be used to deploy pretty much anything. The examples we provide are all for System Center, but if you wanted to modify this to deploy some other distributed system, it's perfectly feasible you could do that. All of the knowledge about how to install something is actually in this giant XML file called workflow. You don't have to know anything about this file. Don't worry about it. If you want to go play with it, go ahead. If you want to find bugs in it and send me feedback, please go ahead. If you want to modify it for your own use, again, it's a toolkit. You can modify this and use it for anything you see fit. What we provide is a set of knowledge around how to install System Center. So it knows nothing about System Center itself apart from what's in the workflow file. So this defines all the roles, in System Center, what all of their requirements are in terms of roles and features, prereqs, what their dependencies are on other roles, how the roles integrate with each other, any firewall rules that may need to be set, and then it also defines all the installables, all the command lines, everything that needs to be downloaded. It has a set of default settings for every setting, any one of which you can modify in variable if you wish, but it defines all the defaults. And it is completely extensible. So if, for example, a partner such as Veeam wanted to modify this to automatically install their management pack with every operations manager installation, that is perfectly feasible. So I'm just going to show you very quickly what this looks like and explain a little bit about how it works. So while we're here, let's take a quick look at the status of what's going on here. So this is our first deployment. You'll see 3 states here. Green is a role that is complete. Green's good, right? Yellow is a role that is waiting on a dependency from some other server before it can continue. So on the 3rd block down there, Virtual Machine Manager, you can see that it says it's waiting on the Operations Manager management server. That's because it's finished installing VMM, it's waiting for OM to complete so it can do its integration with OM. White is something that is still in progress. If anything had failed, it would show up as red. That's our first one. Let's see how our second one's doing. Okay, in this case, our 3-node SQL cluster, and it's the same cluster being used across all components here, is complete. Everything else is continuing. So everything looks good. Let's show you a little bit about that variable file, that workflow file. So this is made up of a number of sections, and I'm not going to go into a lot of detail on this because we'll run out of time. But this defines all of my roles, right? So you'll see in here all of those roles plus a whole set of integration roles for everything that we're going to deploy in System Center. If I look in the details in here, so for example in Orchestrator, this is just saying that depending on which OS version I'm running, I always need the .NET Framework 3.5.1, and that's about all I need. It has a dependency on the database server, so it needs the database server to be complete before it can actually install its role. And then there's a firewall rule here that it needs to set for itself, and then the install itself refers back to this installable section, and I'll show you that in just a moment. That's a fairly simple role. If I take a more complex one, for example, the web components role, here we have, let me just close up the validation. Here I have all the IIS features that need to be installed for this, and you'll notice this is slightly different between, this is Windows Server 2008 R2 and it just has .NET Framework 3.5.1. This is Windows Server 2012. It also has the Framework 4.5, whereas on 2008 R2, because .NET 4.0 is a separate prereq download and install rather than a feature, it lists that separately. And again, there's a dependency on the management server before it starts. There's some firewall rules, and again, a reference back to the install section. So that defines the role and what its requirements and dependencies are. The installable section is what actually defines how all these things get installed. So if I go down to Orchestrator, this is the installable actually defines the media. So there's a download for that, which tells it where to go and download that from. And then there's a number of different things that can be installed from that media. When I'm installing a management server, this is how I detect to see whether it installs, whether it's already installed or not, or whether it's successfully been installed. And then this are the set of switches for the command line to actually go install it. You'll see a number of areas in here where there's variables. So this is where we take the information either from the default values in this file or the values you supply in variable to complete this command line customized specific for your deployment. You'll also see a number of conditions in here. Right, so there's certain things, switches that we only use based on some conditions. For example, we only use the product key if you supply it. Otherwise, we can't give it a blank product key. We just leave that switch off. So this is all the intelligence on how to install System Center. And there is an awful lot of information in this file. This effectively defines everything that we know about how to actually install System Center. The other interesting thing in here is actually integrations. And integrations, you don't have to tell it to do. It automatically knows to do them. So if I'm installing VMM and Operations Manager, it automatically knows that it's got to integrate those at the end. You don't have to tell it to do it, but it does it just as though it's another role. And how it knows which of those to do, it comes from this section. So in here, right here, these two sections here are Operations Manager to Virtual Machine Manager integration and Virtual Machine Manager to Operations Manager integration. Again, it does it based on dependencies. So the first one says, if I've got Ops Manager management server and a Virtual Machine Manager management server, then I need to run this integration. And the target server I'm going to run it on is the one that Operations Manager is running on. The second one says the same thing, but runs a different integration on the server that Virtual Machine Manager is running on. So it knows, once those two are complete, in Ops Manager, I need to go and import some management packs, and then in VMM, I need to go and run some PowerShell that's going to tell it to integrate with Ops Manager. It understands how to sequence all of those things. This really allows us to do any kind of configuration that we want after the setup. We just happen to be using it for integration. We do a lot of validation before we start. One thing I forgot to mention back here on the installer. Failures are interesting, right? We know how to manage cascading failures. We don't roll anything back, right? If something fails, we collect all the logs. You can figure out why it failed, go and correct that, and then just run the installer again, and it will start going through the whole thing again. But because it detects everything it does while it's doing it, anything that's already been complete, it won't try and do a second time. So it is, by definition, restartable. Idempotent, I think, is the clever word that Mark Krasinovich uses. So I'm going to pretend to be him for a while. You can just restart it, and it will go all the way through. Validation is part of how we do that. So everything that we do, we validate whether it needs to be done, and then we do it, and then we validate whether it's successful or not. Before you start, we run a whole set of validation checks. The first version of this we released back in February, version 2.2, which seemed like a good version to start with, didn't do any validation. It just assumed everything you told it was correct and just blasted through and tried to install it. What we found is a lot of people were making typos and not really understanding what some of the system-centered deployment boundaries are, and it was failing. So we added a lot of validation. It validates all the settings in the variable file. So it validates that you've provided FQDNs, all the dependencies are there. So if I want to do an Operations Manager management server, it makes sure you've also specified an Operations Manager database server. One isn't relevant without the other. It validates that you haven't combined things that shouldn't be combined. It validates that you haven't tried to install multiple instances of something of which there should only be one instance. All the required variables in place. All of that just checks contents of the variable file. Then it validates everything it needs to against Active Directory. So are my service accounts valid? Are their passwords valid? Are any other security principles I've supplied, so groups, for example, are those valid? So when we supply those to the installation, will they actually work? And then it does remote checks against the servers you're installing against to make sure that they're correct as well. So does the server actually exist? Do I have admin access to it? Is it the right Windows version? Does it have WinRM enabled? Is the task scheduler running? There's a policy that actually blocks the task scheduler from working even if it's running. We make sure that's not set. Everything we can to make sure that what you've tried to do is likely to work, we validate before we start. I'm going to show you what some of the failures on that look like. So if I go back again to this one here. Okay, so here's a copy of that variable file from that first demo for a full deployment I'm doing. If I were to do something that is less than correct in here, so for example, here's my service manager management server on server SM1. If I were to tell it to install that on OM1, the same server that the operations manager management server is running on, that doesn't work. Those two things are not compatible on the same system. So I'm going to tell it to just do validation. Dependencies are good. Combinations are not good. So it tells me that I've tried to combine things that aren't valid, that shouldn't be put together. So I'm going to go and fix that, put that back to SM1. If I give it a bad password, so instead of the correct password there, if I give it a bad password, try and run this again. I can also tell it if I want to skip certain validations. So if you get frustrated with this validation, it keeps failing and you're sure you got it right, you can tell it to skip validation, see if it works. It probably won't, but you can try it. In this case, I'm just going to skip straight to the Active Directory validation, and straight away it's going to tell me that installer service account is invalid. Either the account doesn't exist or the password I've provided is incorrect. So it's going to go through and check as far as possible everything it can to make sure that the deployment you're about to try and do is likely to be successful. There are still lots of things that can cause it to fail. We can't predict everything, but it will at least attempt to identify all of those things that it should try to stop you from doing. Integrations. PDT completes all automatable component integration, right? So there are a couple of things missing, but everything that we have the ability to automate that integration, we do. Service Manager connectors to all the other System Center components for population of the CMDB. They automatically get created. App Controller registering the VMM server, that gets created for you. Windows Azure Services, it's not on this list, I need to update this slide. Windows Azure Services, if I'm also installing SPF and VMM, it automatically creates a VM cloud provider in Windows Azure Services. Everything that we can automate, we have. The most notable missing integration is Orchestrator. So ironically, Orchestrator, which is our integration product, has no automatable way to register its integration packs. Yes, there was some blog posts a year or so ago by an Orchestrator program manager that has since left the company. They're completely unsupported. There is no automated way to register, deploy, and configure an integration pack in Orchestrator. So there are some missing. We are certainly working to plug those gaps, but everything that we know how to automate that integration, we automatically do for you. Then we do some other interesting things. Component admin groups. System Center, each System Center component has a slightly different method it uses for admin groups. So that is the group that gets access to run the console and use the admin functions of that component after it's installed. Service Manager is the only one that actually requires you to specify a group at installation time. Right? So we require that as input in PDT. Orchestrator optionally allows you to specify an administrator group at installation time, but it doesn't require it. Ops Manager, VMM, and App Controller all take the members of the local administrators group and add those to its administrators group during its own setup, right? Service Provider Foundation and DPM just use the local administrators group. They don't add the members. They just say that is our admin group too. Config Manager, my favorite one, Configuration Manager only adds the account that's installing it to its own admin group during setup. So afterwards, if you go and run the console from somewhere else and you're not running as the same user that installed it, you can't get into it. So you have to go back to Config Manager and go and add to that. What we do with PDT is optionally allow you to specify what you want to be the admin group. We don't require it. The only one we require it for is Service Manager. But if you optionally also add those as variables, it will automatically add those during installation, so you don't have to go and add them as a second step after that component's installed. Then we also automatically configure the console to connect to the right server. If you're running the installer on the system that the console is going to be installed on, we will do this. That's the only one we can actually do it for. So after I've installed Orchestrator and I run the Orchestrator console, instead of it coming up with an RPC error, which is what it does by default, it will automatically connect you to the right server. This is just a reference for the variables in the variable XML file that you would use to specify those. A lot of these slides are really just reference material. We then have a whole set of what I consider advanced configuration. Right? So far, everything is just basic installation. There are lots of other things you can do. Any component setting, so anything that you would usually specify during setup that we have defaulted in the workflow file, you can change the setting for by copying that variable to the variable file. So for example, default installation path. They all default to C program files or program files x86 for Orchestrator, Microsoft System Center 2012, something. If you want to install that on some other drive, you can change that variable. It will change that installation setting. Any setting that's in workflow, you can modify in variable. You can tell it to use existing SQL. In all the surveys that we did prior to the unified installer, we found that it was almost exactly 50-50 in terms of customers that allow their System Center admins to install their own SQL versus those that had a corporate DBA group that did SQL for you, and you're not allowed to do your own SQL, you have to use some existing SQL file. So with PDT, we allow you to say, use an existing SQL server, right? It won't validate that it's correct, it will just attempt to use it. So you need to make sure you've got the right permissions to actually use that and the instance exists. But it will allow you to say, I'm going to use some existing SQL instance. It will allow you to get SQL, quote, right. By this, I mean not use a default installation of SQL which puts everything on the system drive, typically the C drive. A correct installation of SQL separates database files, log files, tempdb files, right? Advanced configuration in PDT allows you to specify those as well. There is, I know, a lot of discussion in virtualization about whether that really matters anymore. I personally believe it does. You still need to be able to optimize that. But PDT allows you to specify all of those locations. It allows you to install SQL clusters. The cluster has to exist first. We don't create the cluster for you. But if the cluster's there, we can install a clustered instance of SQL against that, using either SMB storage or traditional cluster shared storage. It also allows you to deploy a VMM cluster. VMM is the only role that, for high availability, you still have to use a cluster. Everything else just uses multiple instances of a role. But VMM does use a cluster. Again, we allow you to deploy against an existing cluster. We do validate that the cluster exists, but then we'll install VMM in a cluster against it. And then scale out roles. So all the other components where high availability or scale out just means I've got multiple instances of a role. There are 3 different ways that those effectively get installed. There's first, then additional. So the first installation of a role typically creates a database, and then I can install a bunch of other additional roles. Operations Manager is a good example of that. Concurrent, the Orchestrator runbook server is a good example of this. You can install them all at the same time. It works just fine. Sequential is, if I've got multiple roles, they need to be installed one after the other. DPM is actually a really good example of that. I can do multiple DPM servers against a single database, but I can't install them all at the same time because they all attempt to restart the database. So one of them will work, the rest will fail. So they have to be installed sequentially. PDT allows you to do all of those types of scale-out roles. Couple of references for getting SQL right. This is SQL with, I've got 3 drives here, E, F, and G, where I'm separating out the log files, the database files, and the tempdb files. So all of these variables are referenced in the workflow file. You can just copy them into your instance information for SQL, and it will install SQL correctly for you the first time. A SQL cluster, these get really interesting using SMB. So here, all I've said is that this database instance is going to use a default instance, but is going to be clustered. And then that references down to this cluster section. And I specify my service accounts, because clustered SQL needs to use a service account. I specify my paths. In this case, these are SMB paths. I also have to specify the cluster network. And then here I'm saying these are the 3 nodes that I'm going to install this cluster against, and which one of them I'm actually going to use as preferred for this particular clustered instance. Very similarly with SAN storage, with traditional cluster shared storage, I'm saying this is clustered, but instead of those UNC paths, I have paths to drives, and I also have to specify which cluster disks those exist on. We can't automatically detect any of that stuff for you. A VMM cluster, instead of doing a virtual machine manager management server, I'm doing cluster active and cluster passive management servers. So it'll know to do the active one first, obviously using dependencies. I also have to tell it what I want the cluster name to be and what the AD container is. You have to create that AD container first. That's actually one thing we still don't validate. The AD container has to exist and has to have the right permissions for the VMM service account. And then the really strange thing about VMM is the IP address for the cluster. If the nodes that you're installing the cluster on have static addresses, you have to give the cluster a static address. If the nodes have DHCP assigned addresses, you have to let it get its cluster address from DHCP. You can't mix and match those two things. So again, we don't validate that. You just have to understand that when you're deploying VMM. And then scale-out roles, again, this is really just a reference. If I'm installing multiple orchestrator servers, I do the primary one first and then the standbys concurrently. You can do them all at the same time, but if you do them all at the same time, you have no way to predict which one's going to become the primary runbook server. So I actually specify the primary first. For service provider foundation, you just do the first server, then additional servers. For app controller, the same way. For ops manager, again, the same way. Also service manager, those are just additional servers. And then DPM, you just tell it, these are all the servers that are going to be DPM servers. It knows they have to be installed sequentially, so it's automatically going to do that for you. Troubleshooting. There's a lot that can go wrong. This is doing a lot of stuff concurrently. There's a lot that can actually potentially fail. We try and validate anything that could cause it to fail. Doesn't exist, but there are still things that are going to go wrong. But there's lots of information to allow you to troubleshoot. The installer itself logs everything it's doing to the typical app data local folder. There's a log file in there for the all-up installation, and then there's a log file per server. Just writing it twice, because it's easier to read certain ways for certain troubleshooting. A good thing to know about these installation log files is they actually contain all of the full command lines that are being used to do all the installations. So they're actually a really good reference for silent installation command lines. We strip out the passwords, we blank out the passwords, but it does put the full command line in there. Every component that we're installing does its own logging. The interesting thing about that, though, is it's on a remote server. I'm doing all the installs remotely, so all that logging exists on a remote server. And some of those logs no longer exist after the installation finishes. No, I didn't say succeeds. So Service Manager, for example, logs to a temporary folder that when the user account that's running it logs out, in other words, the task scheduler finishes, the temporary folder gets deleted. So if Service Manager failed, it automatically deletes its logs files and you have no way to tell, just because of the way PDT works. So what we do is actually take all those log files and copy them back to the installer system, so you have a copy of them, partly because it's easier to reference them there, but also because sometimes they no longer exist on remote systems. And again, if something fails, everything is restartable. So if something fails, you can correct whatever it was that caused it to fail, restart installer, and it will pick up automatically where it left off. It checks everything, so it takes it a couple of minutes to go through and say, well, previously I had to do this, this, and this. Well, this time those are already done, so I'm just going to skip them all. But you can just restart it, and it'll go right through. Be careful of reboots. So during the initial installation, reboots are just fine. Right? If it needs to reboot something, it will. There are no dependency failures on reboots. It will automatically wait for that reboot and the dependency will succeed. But if you go through, do an installation, something fails and you correct it, or you add something to your deployment to install later, and by the time you restart the install, some of those other components are already being used in production, it is possible that they could get rebooted by restarting the deployment. If something's gone into a reboot pending state, which is actually fairly common, after the initial install, it'll get rebooted. So if you're doing restarts of deployments, just be careful about that concept of something rebooting. I mentioned if you supply a product key, everything gets installed in license mode. If you don't, it gets installed in evaluation mode. There's one thing that you need to note, and that is DPM has different media for license versus evaluation. Right, so the version that downloader downloads, the publicly available one, is the evaluation version. If you supply it a product key, it will fail to install. You need the license version from the volume license site to supply a product key for DPM. Everything else is the same media for both. All of them can be switched from evaluation to licensed. Right? And there's different ways to do it for each one of them. Again, this is kind of a reference. For SQL, you just rerun setup, say switch editions, give it the product key, and it will automatically convert your installation to a licensed version of whatever edition that product key is for. Orchestrator, in the runbook designer, there's a button, you click it, enter the product key. VMM, same way, there's a product key in the console. I think it's actually in Help About in VMM. App Controller and Ops Manager, there's some PowerShell you can go and run to add it. Configuration Manager and DPM, you rerun setup, enter the product key. It does what it calls an upgrade, but basically all it's doing is adding the product key to it. Service Manager is the really interesting one. You can look for it, you won't find it. There is a way to upgrade Service Manager from evaluation to license, but it's a tool that you have to get from support services. It's not actually in the product. But if you did a Service Manager installation in evaluation mode, you did all your customization, and then 6 months later, you realized that it expired, there is now a way to change that to license. All right. Is it done yet? Let's go take a look. So our first one, everything except the last few pieces of Service Manager are installed. Those are still running. That probably got about 5 minutes to go. The second one is actually complete. So we'll start with this one. You'll notice across the taskbar at the bottom here, it's automatically added the icons. Right, so it's added the icon for the consoles here for both Orchestrator and VMM. If I go and run those, it's actually also added the icon for SQL because it's stored in SQL Management Studio for you as well. If I run those, it's going to, instead of prompting you for what server to connect to, it automatically connects to the right server, so I don't have to provide it any information. VMM, same way. Now this is a clustered instance of VMM, so it's actually using the cluster name as part of the configuration of the console, not the server names that it was deployed against. So you see here, it's known which server to go and connect to. It'll just go connect to the right server. App Controller, so let's go to our web-based consoles. App Controller, we do actually specify an App Controller console server. The reason for that is it has to install Silverlight. If you're doing this in a completely disconnected scenario, you'll never get Silverlight on there. So you can specify an App Controller console server, even though it's just a web console, and it will install Silverlight for you. So if I sign in to App Controller, and I'm able to sign in because it's added a group that I'm a member of to the admins here automatically, you'll see in my connections, I automatically have a connection to VMM. That's the post-setup integration. It did that for you. Same thing with Windows Azure Services, if I can remember the URL for this. It uses self-signed certs by default, so they're not trusted. There it goes. Again, this is the current version of Windows Azure Services, not the Windows Azure Pack. This is intended for service provider infrastructure as a service scenarios, but it still uses VMM as its fabric controller for deploying VMs. And if I exit out of the welcome here, this one is actually the VM cloud node. If I wait for that to complete, any second, there it goes. I automatically have a provider registered for the VMM server. It knows I installed VMM and SPF and Windows Azure Services, so it knows the first thing I'm going to do is go and do this, so it's gone and done it for me. Let's see if the other one's done. Okay, he's really close. We'll come back to that, but while we're waiting on it, let me just go show you a couple things in a log file here. So this is a really good example. Everything that this does, this is the main all-up installer log. It's saying everything that it's doing, so it tells you, it's checking to see whether something needs to be installed. If it needs to be installed, it's going to install it, and then it checks to see whether it worked at the end. You'll see these command : entries in here. This is the full command that it's running to do whatever it's trying to do. This is actually an integration one, so it's PowerShell. It's a little more complex. Here's a more typical one. This is the full command line for the setup of the SharePoint web parts part of the Service Manager portal. So you can see the installer log file contains every command line for everything it's doing to actually go do this installation. We also see that we collect all of those log files into a temp GUID folder. So here's each one of the servers that I've collected a log file from. So you'll see things such as all of the SQL log files. Even if it succeeds, I'm collecting all the log files so you can go and reference them later. And there you see it just finished. So you see all those icons appear across the bottom here. The one example I'm going to show you here is actually Service Manager. So after I've installed Service Manager, if I'm doing all of System Center, I need to connect Service Manager to Operations Manager and Configuration Manager and VMM and Orchestrator. Right? Actually, to Operations Manager twice. So there's a whole set of post-setup integration there. I also connect it to other systems for Cube for analysis processing. But because PDT knows it's doing all these things at the same time, it automatically creates all those connectors for you. So just a second. There it goes. Here's my connectors in Service Manager. They all have been pre-created for you. So all of that post-setup integration has been completed. So back to our original questions. How many products make up System Center? This really does make it like there's really only one. Yes, there's lots of components, but there is one product. How long does it take to deploy System Center? We just did the whole thing in an hour. I'm not running on especially fast hardware. It is good, but it's not crazy good. Both of those deployments were running on the same systems. They're two Hyper-V servers and the critical part is actually the storage I/O, and those both each have 6-disk RAID 10 storage. So it's pretty good, but it's not ridiculously good. It's not all SSD. It would be a whole lot faster if it was. How many screens does an installation take? Well, okay, this is a glib answer, but the only thing you have to do is fill out variable XML, so it's really only one screen, right? How many post-setup integration tasks are there? It doesn't matter anymore because you really don't need to understand them as much as you did before. It automatically does it for you. Okay, who's afraid of XML? Anyone that wants to is welcome to write a UI for this, right? And I considered it, but I'm really not a UI guy, so I'm not going to do it. I do have at least one partner that's thinking about it, and we're talking about some way we may be able to provide this. But the XML is really not that difficult. It's editing a text file. You can't get it wrong because it won't do it for you. If you get something in there wrong, you'd have to get something wrong in a really unique way for it to pass validation. So don't be afraid of that XML file. It's actually really easy. This is all available on the TechEd gallery. There's updates posted semi-regularly. I actually posted an update this morning that adds the workflow file that does the Windows Azure Services piece. I've had a request for that over and over the last couple of months since MMS and before. And since the Windows Azure Pack announcement on Monday, we've had lots of people asking about it. So I posted an update to the TechEd gallery this morning. It's all documented on the Building Clouds blog. If you are not following the Building Clouds blog, please go check that out. That's actually our team's blog, and that's one of the primary missions of my team is to blog public information about how to use System Center, how to deploy System Center, just advice on Windows Server and System Center. Go check out that blog. There's also a YouTube video. So the same guy that produced the Brad Anderson video with the Aston Martin for the keynote on Monday produced the video for PDT. He didn't give me an Aston Martin to drive, though, which really upset me. All he did was sped up to 10,000%. So if an hour's too long, there's a video on there that does it in 2.5 minutes. It's really just kind of to show the capability. It's important to note this does not replace software distribution and configuration manager, VM deployment through virtual machine manager, or service deployment and servicing through virtual machine manager. Again, System Center has really good technology to do these things. This is to get System Center there in the first place. This is to solve the chicken and egg problem. So that's PDT. We got about 5 minutes, and there's a bunch of the usual slides at the end here. Please fill out your evals. I'll be around for a few minutes if there are any questions. Also, if there's other things you want to come and talk about this, ask about it. We have a booth down in the expo. Is the expo open tomorrow? Yeah, so we have a booth down at the expo. I'll be there most of the day tomorrow. It's in the server and tools section. It's a building clouds booth. So feel free to come there and discuss any kind of deployment needs you may need. Are there any questions? Yes.
The PowerShell tool, the PDT, where should you execute? On a management workstation, on the Hyper-V host?
Yeah, good question. So I don't think the mic's on. So the question was, where do you execute the installer from? You can execute it from anywhere. What I recommend is you do it from the system that you're installing consoles on, or a system that's not part of the deployment, right? The reason being is if it's on a system that's some other part of the deployment, it's possible there may be a reboot required there at some point, in which case it will cause a cascading failure intentionally. So it's very safe to run it from the system if you have a console system, to run it from there. If not, you can run it from the orchestrator server. That one's usually pretty safe, but the best bet is to run it from some server or workstation that's not part of the deployment. You can run it from a Hyper-V host, yeah. That's no problem. Other questions? The question was the Service Manager AD connector. No, it doesn't do the AD connector, partly because we're not installing AD, so I'm not assuming that you want all of that. I just chose not to do it. That one's a relatively easy one to create. Okay. Looks like there's actually quite a few questions, so I'm going to close right now, and I'll hang around here and answer any other questions you may have. But thank you for coming.